Hello students, let us continue the session on rational numbers. In previous session we have learned associativity in set of integers. We shall continue with the set of rational numbers. Let me consider three different rational numbers, say 1, 2 by 3 and 4 by 5. These three belonging to the set of rational numbers. I need to verify a plus b plus c equal to a plus b plus c. I'll consider the left hand side and the right hand side separately. Here we have a as 1, b is 2 by 3 and c is 4 by 5. Now I should simplify within the brackets first. The LCM is 15, hence this is 10 added to 12. So we get 1 plus 22 upon 15. The LCM of these numbers 1 and 15 is 15. So 15 plus 22, this is 37 upon 15. Let's take up the right hand side. In the right hand side we have a plus b added to c. 1 plus 2 by 3 added to 4 by 5. The LCM of 1 and 3 is 3. So 3 to be added to 2 plus 4 by 5. This is 5 by 3 plus 4 by 5. The LCM of 3 and 5 is 15. If 15 is the LCM, this 5 to be multiplied by 5, it becomes 25, plus this 4 to be multiplied by 3, it becomes 12. We get the sum as 37 by 15. Hence the left hand side and the right hand side are equal. Hence we have verified the associative property of rational numbers under addition. Let's look at the multiplication. With the same example of numbers, we'll consider the multiplication. I need to verify a into b into c is equal to a into b into c. Let's take the left hand side. The left hand side is a into b into c. A value is 1, b is 2 by 3 into 4 by 5. When 2 by 3 and 4 by 5 are multiplied, we are going to get 8 by 15 and the product becomes 8 by 15. Let's take up the right hand side. In the right hand side we have a into b to be multiplied to c. So 1 into 2 by 3 to be multiplied to 4 by 5. The product is 2 by 3 into 4 by 5. We have learned the multiplication as multiplying the numerators to numerator, denominator to the denominator. I get 8 by 15. Hence left hand side and right hand side, they are equal. Hence the associative property of rational numbers under multiplication is verified. The next important property is called as distributive property. It is also known as distributivity. Here, the distribution of multiplication over addition over subtraction is being done. So whenever a is multiplied to the sum b plus c, it can be written as a into b plus a into c. If you observe, the product is being distributed to both a and c. Let us verify this particular property by taking the number system starting with natural numbers, whole numbers, integers, then rational numbers. For natural numbers and whole numbers, I would like to take the example as 1, 2, 3 belonging to the set of natural numbers. For whole numbers also the same example holds true. Here I need to verify A into B plus C equal to A into B plus A into C. So the left hand side is A into B plus C. Let's substitute 1 into 2 plus 3. 2 plus 3, the sum is 5. When multiplied to 1, I get 5. Let's take the right hand side, A into B plus A into C. Here we have 1 multiplied to 2 plus 1 multiplied to 3, which is 2 added to 3, the sum is 5. Hence the left hand side equal to the right hand side. The left hand multiplication, left hand distributive property of multiplication over addition is done. Let's have a look at the distributive property of multiplication under subtraction. What if here we have negative sign? If it is minus, then this would become 2 minus. This will be minus. So it is 2 minus 3, which is negative 1. The product becomes minus 1. So 2 minus 3 is negative 1. So the distributive property of natural numbers has been verified in both addition and subtraction. The same example holds true for whole numbers also. Let's take up integers. Let me take 3 different integers this time. I would prefer taking a positive integer and other 2 negative integers. Here the left hand side is A into B plus C and the right hand side is A into B plus A into C. Let's substitute. It is 5 multiplied to negative 3 added to negative 7. In the right hand side we have 5 multiplied to negative 3 plus 5 multiplied to negative 7. So here it's 5 multiplied to the sum of negative 3 and negative 7 is negative 10. The product is minus 50. And here it is negative 15 to be added to the negative 35. Both are like integers, so their sum with the same sign should be considered. It becomes negative 50. Hence left hand side and right hand side are equal to each other. Let me take the same example 5, negative 3, negative 7 for multiplication over subtraction. So the left hand side is A into B minus C and the right hand side is A into B minus A into C. In the left hand side we need to substitute 5 into negative 3 minus of minus 7. In the right hand side we have positive 5 multiplied to negative 3 minus positive 5 multiplied to negative 7. So here we have 5 multiplied to, this becomes negative 3. Negative of a negative number is positive 7. So 7 minus 3 is 4. It becomes 20. In the right hand side we have negative 15. This becomes negative of negative, it becomes positive 35, and the sum becomes positive 20. Hence, once again we have verified the distributive property of multiplication over subtraction in integers. Let's do the same thing for rational numbers also. Let me consider 1 as one of the rational number, 1 by 2 is another rational number, 3 by 4 as another rational number belonging to the set of rationals. Let me verify the left hand side, a into b plus c, and the right hand side is a into b plus a into c. So 1 multiplied to the sum 1 by 2 plus 3 by 4. So 1 into the LCM is 4, hence the numerator becomes 2 plus 3, which is 5. So 1 into 5 by 4, it is 5 by 4. In the right hand side we have 1 to be multiplied to 1 by 2 plus 1 to be multiplied to 3 by 4. I get 1 by 2 plus 3 by 4. LCM is 4. We get 2 plus 3, which is 5 by 4. So the left hand side and the right hand side are equal. Hence, the distributive property of multiplication over addition is verified in the set of rationals. Let's verify the multiplication over subtraction. I'll consider the same example, 1, 1 by 2 and 3 by 4 belonging to the set of rationals. Let me verify a into b minus c equal to a into b minus a into c. Here, the left hand side will be 1 multiplied to 1 by 2 minus 3 by 4. And the right hand side will be 1 multiplied to 1 by 2 minus 1 multiplied to 3 by 4. Here we have 1 into the LCM is 4. It becomes 2 minus 3. We get it as 1 multiplied to negative 1 upon 4, which is negative 1 upon 4. In the right hand side it is 1 by 2 minus 3 by 4. LCM is 4. We get 2 minus 3, which is negative 1 by 4. So the left hand side and the right hand side are equal again. Hence, the distributive property of multiplication over subtraction is verified in set of rational numbers. Let's discuss another very important property, the existence of additive identity element. Remember this statement, when a is added to 0, I get a, which is same as 0 added to a. Is 0 present in the set of natural numbers? No. So the natural numbers does not have additive identity element. If you look at the set of whole numbers, integers and rational numbers, 0 is present. So the additive identity element is present in the set of whole numbers, in the set of integers, in the set of rational numbers, but not in natural numbers. The same property is discussed in your textbook as a role of 0. So the role of 0 is the same as the existence of additive identity element. Similarly, we have got the existence of multiplicative identity element. In additive identity, you have seen the sum of two numbers, we were getting the same number again. Similar here, when a is multiplied to some number, I should get a. This will be equal to that number multiplied to a. That is 1. So this one is called as multiplicative identity element. If you look at the natural numbers, whole numbers, integers, and rational numbers, in all the four sets, this particular multiplicative identity element is present. Let's look at the existence of additive inverse element. What does it mean? If 5 is added to negative 5, the sum becomes 0. If A is added to B and if you are getting 0, then A is additive inverse of B, or B is additive inverse of A. Given a number, say 10, by adding some number, I should get the sum as 0. It's possible with negative 10. So negative 10 is additive inverse of 10. It is also called as negative of a number. Negative of 5 is negative 5. Negative of negative 5 is positive 5. Remember, in the set of natural numbers and in the set of whole numbers, we do not have additive inverse. If I consider 5, do we have negative 5 in the set of natural, and in the set of whole numbers it's not there. Whereas in the set of integers and in the set of rational numbers, they are present. So the additive inverse element is present in the case of integers and rational numbers only. Similar, by multiplying a number with another number, if I get the product as 1, then I say that A is multiplicative inverse of B. If I have a number 5, I need to multiply 1 upon 5 to get the product as 1. If I have a number 3 by 4, I need to multiply 4 by 3, then the product becomes 1. So, in the set of natural numbers, whole numbers and integers, we do not have multiplicative inverse, whereas in the set of rational numbers, there is a multiplicative inverse. So the multiplicative inverse is also known as reciprocal. The reciprocal of a number is referred to as multiplicative inverse. What is reciprocal of 1 by 5? It is 5, because on multiplication we get the product as 1. The reciprocal of 5 by 7 is 7 by 5, because on multiplying them I get the product as 1. These are few of the properties which we need to learn in this particular chapter. That's all for today's session. Thank you.